At Arizona State University, we're bringing world-class education from our globally acclaimed faculty to you. Earn your degree from the nation's most innovative university. Online. That's a degree better. Learn more at asuonline.asu.edu.
The science behind self-awareness is a fascinating convergence of neuroscience, psychology, and even biology. It moves the concept from a philosophical abstract to a tangible, measurable phenomenon. Here's a breakdown of the science, from the brain networks involved to the evolutionary purpose and how it develops. What is self-awareness? A scientific definition. Scientifically, self-awareness is often broken down into two key types. Public self-awareness, knowing that we are being observed and how we are perceived by others. This involves understanding social norms and adjusting our behavior accordingly. Private self-awareness, the ability to introspect and recognize your own internal states, including thoughts, feelings, desires, and biases. It's your inner monologue. The most fundamental scientific test for basic self-awareness is the Mirror Self-Recognition Test, MSR. An animal or human child is marked with an odorless, non-tactile dye, like on the forehead, and placed in front of a mirror. If they use the mirror to investigate the mark on their own body, they demonstrate self-recognition. The brain's self-awareness network. Self-awareness isn't housed in one single self-awareness center. Instead, it emerges from the coordinated activity of a distributed network of brain regions, primarily in the cerebral cortex. The key players are brain region, function in self-awareness; anterior cingulate cortex, ACC, the conflict monitor. It's involved in error detection, motivation, and regulating emotional responses. It helps you notice when your actions don't align with your intentions, a key aspect of self-awareness. Insula, especially the anterior insula, the interoceptive center. This region maps the internal state of your body, your heartbeat, gut feelings, temperature, and emotions. It's crucial for feeling embodied and connecting physical sensations to emotional states, e.g., I feel anxious because my heart is racing. Prefrontal cortex, PFC, the executive director. Specifically, the medial prefrontal cortex, MPFC, is involved in narrative self-reflection, thinking about your own personality, traits, and life story. The ventromedial PFC, VMPFC, links emotional value to self-relevant thoughts. Temporoparietal junction, TPJ, the perspective taker. It helps distinguish between self and other, which is fundamental for understanding that you have a unique perspective separate from those around you. How they work together. When you reflect on yourself, this network lights up. The insula provides data on your bodily state, the ACC flags discrepancies or emotional conflicts, and the prefrontal cortex weaves this information into a coherent narrative about you. The development of self-awareness. Self-awareness develops in stages, closely tied to brain maturation. Birth, 1 year. Babies have a rudimentary sense of self, understanding they are physically separate from their caregivers, but lack higher self-reflection. I-18 to 24 months. Most human children pass the mirror test. This coincides with a growth spurt in the right hemisphere, particularly the anterior insula and anterior cingulate cortex. 3 to 5 years. Children develop a theory of mind, the understanding that others have their own thoughts and perspectives. This is a sophisticated extension of self-awareness. Adolescence. The prefrontal cortex undergoes significant remodeling. This period is marked by intense self-consciousness, public self-awareness, as teens refine their sense of identity. Adulthood. With practice, adults can develop deeper private self-awareness, learning to better identify and regulate their emotions and biases. Which other animals are self-aware? The mirror test suggests that self-awareness, at least in this basic form, is rare in the animal kingdom. The short list of animals that have consistently passed the test includes great apes, chimpanzees, orangutans, gorillas, bottlenose dolphins, orcas, elephants, European magpies, remarkable as they are not mammals. This distribution suggests that self-awareness evolved independently in different lineages with complex social brains. The evolutionary why. Why did self-awareness develop? From an evolutionary perspective, self-awareness is metabolically costly. Big brains use a lot of energy, so it must confer significant advantages. Theories include social navigation. Living in complex social groups requires understanding your own status, reputation, and relationships. Did my action offend that larger, stronger individual? Future planning and goal. Setting. To plan for the future, you need a concept of a self that will exist later and have needs. I should store food for winter. Empathy and cooperation. Understanding your own emotions, private self-awareness, is a prerequisite for understanding the emotions of others, empathy, which fosters cooperation and group cohesion. The science of cultivating self-awareness. The brain's plasticity means we can strengthen the self-awareness network. Practices like mindfulness meditation have been shown to physically change the brain. Increased grey matter. Studies show meditation can thicken the cortex in the insular and prefrontal cortex. Strengthened connections. It enhances connectivity between these regions, making the self-awareness network more efficient. By focusing attention inward on breath and bodily sensations without judgment, meditation is essentially a workout for the insular and ACC, honing our ability to observe our inner world. Summary: the scientific view. In summary, the science reveals that self-awareness is not a mystical quality but a complex cognitive process rooted in specific, measurable brain networks. It developed as an evolutionary adaptation for social living and future planning, matures throughout childhood, and can be actively cultivated through practices that train the relevant brain regions. It is the remarkable ability of the brain to turn its attention inward upon itself,